In our second question for Module 6, we're going to solve another equation. This time our equation is cosine squared x plus 5 sine x minus 7 equals 0. And we're given a restriction on x. X must take values between minus pi and pi. This is quite common when dealing with equations with trigonometric functions like cosine and sine. Okay, so the first thing we need to do here is stare at this weird-looking equation and think about which method we'll use to solve this. When you look at this, it looks a little like a quadratic equation, except our usual unknowns, say x, is replaced by a trig function. That's sort of okay, but the problem here is we have two different trig functions appearing in our equation. We have a cosine term and a sine term. So we can't treat it as a usual quadratic equation in disguise. But now we have to start thinking about our trig identities. And anytime you're dealing with a question with a trig function, most of the time, you have to recall one or more trig identities. What we're going to use for this question is probably the most important trig identity of all, and that's the identity that cosine squared plus sine squared is always 1. Okay, so let's start by recalling that cosine squared x plus sine squared x equals 1. And so what that allows me to do is replace the cosine squared term in this equation with something involving sine squared, because we have a sine x already there, and I'll be able to rewrite my equation with only sines appearing. Okay. Now, if we just rewrite this trig identity in terms of cosine squared, we obviously get cosine squared x is 1 minus sine squared x. We're just taking that sine squared term to the right-hand side. And so now, in this term, in my original equation, I'm going to replace with the 1 minus sine squared x. Rearrange, and we'll get something looking more like a normal quadratic. Okay, so we have cosine squared plus 5 sine x minus 7 is equal to 1 minus sine squared x plus 5 sine x minus 7. And if we just fix this up, we get a minus sine squared x. We have the plus 5 sine x, and then 1 minus 7 is minus 6. So we've rewritten the left-hand side of our original equation. Okay, so we are solving minus sine squared x plus 5 sine x minus 6 equals 0. Or, if you really don't like this minus term in front of the highest power of the sine x, we can just times everything by minus 1 and rewrite this as sine squared x minus 5 sine x plus 6 equals 0. And now this really is a quadratic equation, but instead of something like x or a or b or y, our unknown is sine x. And we've got sine x squared minus 5 lots of sine x plus 6 equals 0. So what I'm going to do is just factor this just like I do for every other quadratic. And once it's factored, we can read off the solutions. So our left-hand side, our quadratic was sine squared x plus 5 sine x minus 6. Let's check that I've got that right. Minus 5 plus 6. And I don't have it right, so I'm glad I checked. It was minus 5 plus 6. Okay, now let's factor that as we do quadratic. So we're after two numbers whose product is plus 6 and whose sum is minus 5. And so if you think about that, you get minus 3 and minus 2. So this is equal to, now my unknown is sine x, minus 3, sine x minus 2. And now when we're trying to solve this equal to 0, then we just want sine x minus 3 to be 0 or sine x minus 2 to be 0. So the solutions are sine x equals 3 or sine x equals 2. Now we're not quite done, because when you're given an equation and ultimately the unknown is x, you want to find values for x, not values for sine x. So now we've got pretty standard trig equations here. We've got values for sine x, and we can think about using the inverse sine function to work out the actual values for x. Okay, but immediately there's an issue with this question. And maybe, hopefully, these equations made you feel a little uneasy as soon as I wrote them down. If so, that's a good thing, right? Because what can you tell me about the sine function that always has values between plus and minus 1, right? You should all remember the sine, cosine, and tan curves, but remember that the sine function always sits between values plus and minus 1. Right, it oscillates forever and comes down here. So now if we come back to these equations, what values of x is sine x equal to 2 or sine x equal to 3? Well, there aren't any, because sine x can only sit between plus and minus 1. So in fact, our original equation has no solutions. Since sine x can never be 2 or 3 or anything beyond plus or minus 1, our equation has no solutions.